Alright, so for this last part of question 10, it would like us to find the reaction force of box C on box B. So if we look back at our diagram that we drew earlier, our free body diagrams, it's asking us to find the reaction force of C on B. So if we look at our diagram, really the force that we're looking for in this third question is this one right here, right? It's asking us to find force C on B, right? And we know that that's going to be the same as this force right here, right? It's the equal and opposite reaction force. And so again, with these problems, there's often multiple ways to solve them. Some of them might be a little bit easier than others. But if we look at this, what we got to do is really look at these other forces and ask ourselves, do we know what those forces are? Or can we figure them out? So the force of kinetic friction acting on B is going to be simple enough to solve, right? We just use mu k mg. The force that A has on B is what we calculated in part B of the problem, right? And so we can, with these two forces, plus knowing that the net force is going to be equal to the mass times the acceleration, we can find this force. Looking at block C, it's actually another way of solving the problem, right? The only force acting on this block, other than force B on C, is this force of kinetic friction. And so it actually might be a little bit simpler to solve using block C rather than block B, right? We have an extra force in there. There's maybe a little bit more room to make a mistake, but really, in principle, you could go with either way and get the correct answer. So let's try by looking at block C in particular. Alright, so looking at the free body diagram that we have on the left, we know that the net force acting on block C is going to be equal to the force of gravity plus the normal force plus the force that B has on C plus the force of kinetic friction. Again, just as we did in part B, we can break all of these down, well, not all of them, but as many as we can into further. So we know that the net force is going to be equal to the mass times acceleration times Newton's second law. We have the mass and the acceleration are both given to us in the question. Our force that B has on C is what we're looking for, right? Our force that B has on C is our goal. And then finally, our force of kinetic friction is going to be minus mu k mg, right? And that's exactly this for the same reason as we did in part B. This negative reason again is, or negative sign, is because it's going in the opposite direction of the net force and this force that B has on it, C. And so now, really, all that's left is to put our numbers in. We know that the mass of this box C, the very last one, is 25 kilograms. The acceleration is the same as the system, which is 1.2. This is going to be equal to the force that B has on C minus 0.15 times 25 times 9.81. And then we just need to rearrange this. And so what we get is 30 plus 36, 7, 8, 7, 5. And that's going to be equal to the force that B has on C. And so we'll put that into our calculator. And we get a force of 66.7875 newtons east. But again, remember, our goal is to find the reaction force, the force that C has on B. And so the force that C has on B is going to be the same magnitude, but in the opposite direction, right? So that's going to be minus 66.7875 newtons east, which with rounding is going to be 66 newtons west.